Our next unit is thermochemistry, and we can define thermochemistry as the study of energy changes that accompany chemical reactions. And whether these reactions give off energy or absorb energy, they can be of practical importance to a chemist. So we're going to investigate these types of reactions. But before we dig deep into the topic of thermochemistry, let's kind of define a few terms. The first one is energy. And energy is the capacity to do work or transfer heat. And work then can be defined as the product of force and distance through which the force moves. And if we wanted to express this in an equation, we can say that work is equal to force times the distance. We also know that force is equal to mass times acceleration. So we can rewrite this to say that work is going to equal the mass times the acceleration times the distance. And if we look at the particular units that we're going to use for work, the SI unit for mass is kilograms, the acceleration would be meters per second squared, and the distance is in meters. So if we multiply all these units together, we get kilograms times meters squared per second squared. And this unit is going to be known as the joule, which we'll abbreviate with a capital J. And the joule is going to be the SI unit for energy. So when we look at these reactions that are going to take place, we need to define two things. We need to define a system and a surroundings. So our system is what we are interested in. And this will be defined by the chemist. And the surroundings are everything else. So we can define the system as a coffee cup and the surroundings of everything else. The system can be the planet Earth and the surroundings can be everything else in our solar system. The chemist can define this, and we're going to look at how work or how energy is transferred from the system to the surroundings and vice versa. Okay? So a couple other things that we can then discuss is the heat. So if Q, and Q is how we're going to abbreviate heat, is the heat energy absorbed or released in a reaction for a constant volume process, the Q, and we're going to use a subscript V for constant volume, is equal to delta E, where delta E is the change in the internal energy. And a device used to measure QV is called a bomb calorimeter. We can also look at a process that happens under constant pressure. So for a constant pressure process, and I'll note that most chemical reactions happen under constant pressure conditions, our Q at constant pressure is going to be equal to delta H. And delta H we're going to define as the change in enthalpy. And the sign of delta H is going to give us some type of significance. So if delta H is negative, then we know that heat is released, and we're going to have an exothermic process. If delta H is positive, heat is absorbed, and we're going to have an endothermic process. So by knowing the sign of the delta H, it's going to tell us a little bit of information about this. And in the next video, we'll talk a little bit more specifically about what heat is and what it will depend on and how we can use that in some calculations.